So we had about 25 students tonight, and there are more that couldn't make it this evening. They had other obligations, but it's a sign that we've got a strong team, lots of students coming together to answer these challenging questions. And they've broken up into teams where some of them are focusing on electronics, some of them are focusing on the power system and the structural system and the propulsion system. And they're learning to work together where they know that they have to tell the other teams, the other elements of the craft, if you will, what their choices have been and how they fit together, so that in the end, once we start building and integrating the system together, the parts will work together. And the team has to work together in order for the parts to work together.
So recently I just met everyone that's on my team, and the big challenge is just getting everyone all together at the same time, and then having an agenda and going through it and making sure our meetings are productive. And in addition to that, by the nature of the structures team, we don't really know what we have to build until the other subsystems, like the fuel, tells us what size tank we're going to use, and then we can take that knowledge and design around it.
Now we're at the point where we need something faster, more robust, more of a full operating system. So we're looking at more advanced hardware, going up to a real operating system, Linux in this case.
Also, just safety. Working with a lot of these fuels are very, very dangerous, and that's been another challenge. Is how can we, as college students, overcome those challenges of safety? What kind of training do we need? Can we even purchase, this kind of fuel? Is it, beyond our spectrum of what danger we can handle?
So, from where we are now, our next step is to continue doing the research that we've been doing on pretty much any issue related to the power systems, from voltage conversion to load isolation or anything of that nature. But more importantly, once we start getting power requirements from the other groups, we can take those numbers and put them into what we've looked at already, and start picking out parts, batteries, voltage converters, and even wiring for the voltage buses.
The next phase that we're getting into is the exciting part where we actually get to make fire. And that's the most exciting part, but at the same time it's the most dangerous part. I'm personally taking it on me to try to make sure that everyone is as safe as possible and that we don't have any injuries.
Just as we expected, the core of this system, the most important part is the rocket engines and the propulsion system as a whole, and those are going to drive requirements for all the other subsystems.
We have to make a few key decisions coming up in the short term about the fuel system and about the thrusters, stuff like that. Because a lot of the other subsystems are driven from those choices. So in the short term, those choices are going to be very important and high priority. In the long term, a couple months from now, I see us really having a concrete design and really starting to focus on the details of each subsystem and really getting down to the the true grit of space engineering.
The students identified the key challenges that we face in this demonstration craft, and those are the same key challenges that we're going to meet in the design of the lunar craft. So overall, I'm very pleased with the way that things went tonight. We have a clear path forward, and we know what the biggest challenges are to meet in the next week.